Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Matrices and Determinants. Topic Determinants. Subtopic Consistency, Inconsistency and number of solutions of system of linear equations by examples. Solving system of linear equations in 2 or 3 variables having unique solution using inverse of a matrix. Exercise 4.6. Application of determinant and matrix. Consistent system of linear equations. A system of linear equations is said to be consistent if its solution exists one or more. Linear equation kanglup ama consistent oi haigani solution ama natraga yamna leirabadi. Inconsistent system of linear equations. A system of linear equations is said to be inconsistent if its solution does not exist. Linear equation kanglup ama inconsistent haigani solution amata leitrabadi. Solution of system of linear equations using inverse of a matrix. Linear equation kanglup ama inverse of a matrix sizinaraga putokpa. Let the system of linear equations be ax plus by plus cz plus d, px plus qy plus rz equal to s, lx plus my plus nz equal to t. The system of linear equations in matrix form can be written as mathak ki system of linear equation asibu matrix form da sumna ithokpa yai ax equal to b, where capital A is the matrix formed by the coefficients and x is the column matrix formed by unknowns and b is also column matrix formed by the constants. If determinant of A does not equal to 0, then A is non-singular matrix and hence A inverse exists. Determinant of A C 0 tadrabadi haibadi non-singular matrix orabadi A inverse laigani. Hence ax equal to b sigi equation mathak equation asida both side A inverse na purirabadi we get this. Matrix multiplication is associative A inverse ke A grouping same kharo asumna A inverse into A gidi I lerani ix equal to that gives x equal to A inverse b. This gives the required solution. Masigi equation asina puthokadaba solution p gani. Give the criterion for consistency of a system of linear equations. Linear equation ama consistent oiba natraga oidaba lepnanabagi criteria singdu piu. Let the system of linear equations be ax equal to b, where A is the coefficient matrix and x is the column matrix formed by unknowns and b is also the column matrix formed by constants. The conditions for consistency are as follows. Consistent oibagi conditions singadudi. If determinant of A does not equal to 0, then the system is consistent with unique solution. Determinant of A is 0 tadrabadi equation kanglup ase consistent oi aduga solution na amakaktamak laigani. If determinant of A is 0 and adjoint A into B is 0 matrix, the system is consistent with infinitely many solutions. Condition ani suba chumabadi equation kanglup ase solution laigani in masing thingam dana laigani. If determinant of A is 0 and adjoint A into B does not equal to 0 matrix, the system is inconsistent with no solution. Condition ani suba chumlabadi equation kanglup ase solution laitaba kawi. Exercise 4.6. Examine the consistency of the system of equations. Makhada piriba equation kanglup singa sige consistent oi oidabadu puthu. Piramiba ruma equation 1 gi C matrix form da sumna ire ax equal to b, where A is column coefficient matrix 1 2 2 3 and x is column matrix formed by unknowns xy, b is what column matrix formed by constants. Now determinant of A square matrix asigi determinant putoksi 1 into 3 3 minus 2 into 2 4, that is minus 1, which does not equal to 0. So A is a non-singular matrix. A is a non-singular matrix ni. Hence, the system of equations is consistent with unique solution. Kanglup equation kanglup ase consistent with the solution lay amasu solution do amakaktamaksu oigani. Assume na Roman number 2, question number 2 is so 1 ga manare. Let us try C. 3 try to C. Ax equal to B, where A is coefficient matrix and X is column matrix formed by unknowns, B is also column matrix formed by constants. Now determinant of A putoxi 0 tare. Although the further test is required, that is adjoin A into B. Adjoin A the 2 by 2 matrix ke adjoin the intercept the two diagonal elements. I will the 6 ka 1 ga sumna irani. Non-diagonal anisida minus the puriro minus 1 we get minus 3 minus 2. B given to the 5 at multiply to we get a column matrix of 6 minus 2 which does not equal to 0. The condition anisit chumlabadi thus determinant of A is 0 and adjoint A B does not equal to 0. The system of equations is inconsistent, having no solution. Question number 4. Consistency test tausi. Equation kanglup si matrix form the Ax equal to B, where A is this, B X equal to this and B equal to this. Now determinant of A test tausi mahaki value putoxi value evaluate to matamda ikon A phange, which does not equal to 0. A the 0 nataba number ne. Thus the system of equations is consistent. System of equations are consistent or consistent with unique solution. Number 5. 5 asisu consistent test tausi. Implies Ax equal to B, where A is coefficient matrix, X is column matrix formed by unknowns, B is column matrix formed by constants. Now determinant of A first order expand of Tosi we get 0. We have to test adjoin A into B. Determinant of A 0 or badi atopa test ama makata na tobo matau tari, that is adjoin A into B. Now adjoin A ke damakta di achobo process amani we have A1 1 minus 5, A of 1 2 minus 3, A of 1 3 minus 6, A of 2 1 is 10, A of 2 2 is 6, A of 2 3 is 12, A of 3 1 is 5, A of 3 2 is 3, A of 3 3 is 6. Co-factors sige transpose to in, therefore adjoin A the first row sige transpose the first column da la ani. Assume the second row elements in the second column da, third row elements in the third column da la. Now adjoin A into B, the adjoin A value pisel of B value pisel as multiply to see we get a column matrix which does not equal to, which is not zero matrix tadre. Thus determinant of A is 0 and adjoin A into B does not equal to 0. Hence the system of equations is inconsistent orani. Question number 6 similar to question number 5. Question number 5 ka chap mana record pe ai mamani. Solve system of linear equations using matrix method. System of linear equations si matrix method sizinaraga solve tausi. Here Ax equal to B, where A is this, X is this, B is this. Now determinant of A is 15 minus 14 equal to 1 does not equal to 0. Implies A is a non-singular matrix. Therefore A inverse exists and hence X equal to A inverse B. For adjoin A ke damakta di cofactor puto si A11 is 3, A12 is minus 7, A21 is minus 2, A22 is 5. Therefore adjoin A is transpose the first column, second row, second column. Therefore A inverse is 1 by determinant. Determinant ki value di 1 tahore 1 by 1 into adjoin A. This is lastly we get this. Hence X equal to A inverse gives A inverse ki value P of B ki value P rasi. X have a city column matrix formed by unknowns ni si irani mahakidi multiply to si phange simplify to the 2 3 matrix ani si manarabadi implies X equal to 2 and Y equal to minus 3, which is the required solution. Number 8, that is solved similarly. The system of equations can be written in matrix form as Ax equal to B, where A is equal to 2 by 2 matrix, X is column matrix formed by unknowns, B is column matrix formed by constants. Now determinant of A is I minus plus 3, that is 11, does not equal to 0. Therefore, A inverse exists and hence AX equal to A inverse B. But A inverse is what? 1 by determinant of A into adjoint A. 1 by determinant, the value of determinant is 11. Adjoint A of 2 by 2 is shortly written as 4, 2 and minus 1 of probability 1, minus 1 of probability minus 3. Therefore, X equal to A inverse into B. B की value दी minus 2, 3 multiply तौरसी we get this. Assume X habisidi column matrix formed by unknowns irani 11 simanung that divide tokthokadu we get this. Equating taurabadi X equal to minus 5 by 12 and Y equal to 12 by 11. For question number 9, similarly we can solve. Lastly, X equal to 4 by 11 and Y equal to minus 13 by 11. Solve the system of linear equations using matrix method. Question number 10. Matrix method the system of equations can be written in matrix form as Ax equal to B, Y A is equal to this, X is equal to this, B is equal to this column matrix. Now determinant of A is 4, which does not equal to 0. Therefore, A inverse exists and hence X equal to A inverse into B. But A inverse is what? 1 by determinant A into adjoint A. Their respective values are this. Therefore, X equal to 1 by, this is the value of A inverse and this is B. X can be written X, X, Y. This is multiplying, we get this. Lastly, X equal to minus 1 and Y equal to 4. Question number 11. 3 unknowns. The system of equations in 3 unknowns can be written as X equal to B, where A is this matrix, X is column matrix, B is also column matrix. Now determinant of A expanding in the first row we get 34, which does not equal to 0. Therefore, A inverse exists and hence X equal to A inverse into B. Now cofactor of A11 is 13, A12 is 5, A13 is 3. Similarly, for second rows, A21 is 8, A22 is minus 10, A of 23 is minus 6. For second row, third row, A of 31 is 1, A of 32 is 3, A of 33 is minus 5. We have found out the 9 cofactors. Therefore, adjoint A is this matrix. First row, first column, second row, second column, third row, third column. And hence A inverse is 1 by determinant whose value is 34 into adjoint. Therefore, X equal to A inverse into B. Using this relation, we get this. X1 multiply, we get lastly this. Therefore, this can be written as X, Y, Z, equating both corresponding values. We get X equal to 1 and Y equal to half and Z equal to minus 3 by 2. Question number 12. We have to solve by using matrix method. Similar to question number 11. The system of equations can be written as Ax equal to B, where A is coefficient matrix, X is column matrix formed by unknowns, B is also column matrix formed by constants. Now determinant of A expanding in the first row we get 10, which does not equal to 0. Therefore, A inverse exists and hence X equal to A inverse into B. We have A11 cofactor of the element occurring in the first row and first column, that is 1. We get 4. A of 1, 2 is minus 5. A of 1, 3 is 1. A of 2, 1 is 2. A of 2, 2 is also 0. A of 2, 3 is minus 2. For third row, A of 3, 1 is 2. A of 3, 2 is 5. A of 3, 3 is 3. Therefore, adjoint A is transpose of the first transpose of the matrix formed by the cofactors. First row, first column, second row, second column, third row, third column. And hence A inverse is 1 by determinant whose value is 10 times of its adjoint. Using the relation X equal to A inverse into B, we have this. Multiplying the second two matrices, we get this. And dividing by 10 to each element of the column matrix, we get 2 minus 1, 1. Comparing X equal to 2 and Y equal to minus 1 and Z equal to 1. which are the required solutions. Solve the system of linear equations using matrix method. The system of linear equations can be written in matrix form as Ax equal to B, where A is coefficient matrix form of 3 by 3 and X is column matrix form by unknowns and B is also column matrix form by constants. Now determinant of A, expanding in the first row we get 40, which does not equal to 0. Therefore A inverse exists and hence X equal to A inverse into B. That is, X is given by product of A inverse and B. Firstly, we have to find out cofactors of first row A11, A12, A13. For second row, A up to 1, A up to 2, A up to 3. For third row, A up 3, 1, A up 3, 2, A up 3, 3 is this. Therefore, adjoining is transpose of the matrix form by the cofactors. We get this first row, first column, second row, second column, third row, third column. And hence A inverse is 1 by the value of determinant of A, that is 1 by 40 times of its adjoint. Using the above relation, that is X equal to A inverse into B, we get this. Multiplying the last two matrices, we get this. And again dividing by 42 is element, we get a 1, 2, minus 1, equating X is 1, Y is 2, Z is minus 1. Question number 14 su atai mamang da lehori ba 13 14 ga manare. The 14 su 11 12 13 ga manare. 15. If A is equal to this, find A inverse. Using A inverse, solve the system of equations. Firstly, we have to find out A inverse. Now find out determinant of A, which is equal to minus 1. Therefore A inverse exists. A inverse exists. Therefore, A11 is 0, A12 is 2, A13 is 1, A up to 1 is minus 1, A up to 2 is minus 9, A up to 3 is minus 5, A up 3 1 is 2, A up 3 2 is 23, A up 3 3 is 13. Therefore, adjoint A is transpose of the matrix formed by the cofactors. First row, first column, second row, second column, third row, third column. Therefore, and hence A inverse is 1 by determinant A into adjoint A, this. But the given system of equations can be written as in matrix form, we get this. And solving, multiplying the A inverse of the first matrices, we get this, and which is what, whose value is found to be this. Substituting its corresponding value and multiplying these two, we get this. Therefore, X equal to 1, Y equal to 2, Z equal to 3. Question number 16. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. Find the cost of each item per kg by matrix method. Hariba onion kg marigi maman, gehu kg ahungi maman, cheng kg anigi maman apun badu rupees 60 ni. Asumna onion kg ani aduga gehu kg mari, rice kg taruki maman rupees 90 ni. Onion kg taruk amasung gehu kg ani, cheng kg ahungi maman lupa 70 orabadi. Item khuding maki item is item gi cost price kaya no hangbani. Let rupees X and rupees X, rupees Y, rupees Z be the cost of 1 kg of onion, 1 kg of wheat and 1 kg of rice respectively. Then by given condition we get 4x plus 3y plus twice z equal to 60. Again twice x plus 4y plus 6z equal to 90. And 6x plus twice y plus thrice z equal to 70. This system of linear equations in 3 variables can be written in matrix form as this, where A is equal to this and B is equal to column matrix form by unknowns and B is column matrix form by constants. Now determinant of A, expanding in the first row we get 50, which does not equal to 0. Now A of 1 1 is 0, A of 1 2 is 30, A of 1 3 is minus 20, A of 2 1 is minus 5, A of 2 2 is 0, A of 2 3 is 10. A of 3 1 is 10, A of 3 2 is minus 20, A of 3 3 is 10. Therefore, adjoint A is transpose of the first row, first column, second row, second column, third row, third column. Implies A inverse is 1 by 50 into its adjoint. Therefore, x equal to A inverse into B gives x की value distillate, A inverse की value distillate, B की value distillate, matrix ani se multiply toro 15 ne divide toro body we get 5 8 8, equating x equal to 5, y equal to 8, z equal to 8. Thus, cost of 1 kg of onion is rupees 5, cost of 1 kg of wheat is rupees 8, and cost of 1 kg of rice is rupees 8.